On record. All right, example 11. Example 11. Sketch at least one cycle, blah, 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 blah. Okay, so what we're going to do, we're going to put it in standard transformation form. Is it already? No, not quite. There's a couple things, right? We need to get the 3 that's in the front, single floating term. We need to get him to the back. And then inside, the x term is first, but I got to factor out a pi fifth. So a little bit of a housekeeping first. F of x is positive 2 cosine parentheses plus 3. And now I'll pull out a pi fifths. Parentheses, I know that's going to be an x. I'm pulling out a positive pi fifth, so I know it's still going to be minus. So what do I get when I pull a pi fifths out of a 3 pi fifths? 3. Yeah, 3. Okay. So good morning. So that looks like that's it. Okay. Now look at your b value. Is it negative? No, we don't want to graph with a negative b value. Had it been negative, what would we do? Would we bring it out front or forget about it? We will forget about it in this case. Good, because it's cosine, it's an even function. If it were sine with a negative, we would bring it out front. Okay, good. Just a quick review. Hello, good morning. What? There's just like a little tiny bag of Doritos that's been there for a couple of weeks. Yeah, sorry. Yeah. I'm gonna see my mother-in-law again this weekend and I'll raid her spare bedroom. Yeah. Next week is the last week? Okay. All right. All right. Let's see. Okay, so let's go down the side and do our little alphabet, right? A, B, C, D, P, and R. And this is just for your benefit. So I'm not gonna grade it if it's like equals versus colons or anything like that. So the amplitude is 2, straight up 2, right? No flipping or anything. The B value is of course pi fifths. So we're gonna see pi fifths of a cycle between 0 and 2 pi. So that is going to affect the period. So the period is going to be 2 pi over pi fifths. I always find it right after I find B. And if you stay change flip, you get 10. Okay. The pi's will divide out and 5 times 2 gives you 10. Okay, cool. So it's going to take 10 units. Now, notice that that's actually pretty cool because the pi is divided out. There's not going to be any pi on the x-axis. We're going to be counting by just numbers, right? Without pi's, not irrationals. All right, and then the C value, it's going to be right 3. And then the D value is up 3. And from there, you could just say SA at y equals positive 3. Yeah. And then your range, remember the range is your D value minus A. So what's 3 minus 2? Well, that's 1. And then your D value plus A, that's 3 plus 2, that's 5. So your range is 1 to 5. So your graph lives entirely above the x-axis. Okay, so from there we can start making our graph. We'll draw a y-axis, and since everything is above the x-axis, you can draw your x-axis a little bit lower. Now you can go ahead and do the vertical axis right away if you want. There's 1, 2, 3, 4, 5, something like that. If you want to put individual tick marks, you can, but you really don't need to. Put one at the low, put one at the high, and then visually bisect it, right? Cut it in half. And that should be the midpoint, which is 3. Okay, and then you can go ahead and draw your little horizontal line. That's your new x-axis. That's your sinusoidal axis. But now the horizontal stuff, right? We're moving everything right 3 units. So we're going to have to get new marks. So let's see what that's going to look like. Here's our sacrificial x-axis. Here is the y-axis 0. And we're going to go out the length of one cycle, which is the period. So that's going to be 10. We'll call this 10. You could bisect that to get 5, right? Half of 10 is 5. And then do that half, and you get 5 halves. Now, because there's no pi's in here, if you want to call half of 5 2.5, that would be fine. It doesn't really matter to me. What's that? Or you just put 5 over 2, either one. I'm okay with either one. They're both exact. And then give yourself one negative. So that would be negative 2.5. And then if you want, you can put one here and call it, of course, 5 plus 2, that's 7.5, so on and so forth. So these would be the marks if there were no shift. But there is a shift, right? The shift is on. We're moving everything right 3 units. Uh-oh. That's picking up the graph and moving it over now and not setting it down in the same track. If we were picking it up and moving it over a multiple of 2.5, like 2.5 units or 5 units, it would set down in the same marks, but we have to have new marks. So let's see what we're going to do. The new y-axis, that's exactly why we do this. Yes, so we can visualize that. Numerically, you can just add 3 to everything, right? Moving everything right. So 0 becomes 3. And where's 3? Well, it's to the left of 5, but it's to the right of 2.5. And it's going to be closer to 2.5. So there is 3, and there's your new y-axis. Now, here's what you want to do. Where would negative 2.5 go if you add 3 to it? To 0.5, right? So you're going to have another mark there. So that's important. That's the one that a lot of people miss. You're going to have your new y-axis is at 3, but there's another critical value now between 3 and the y-axis, okay? And that's going to be at 0.5. So again, the 2 things that I'm looking for spacing-wise, because you're all in honor class, is this. What is the spacing between the y-axis, which is no longer a critical value, and your first positive critical value, 0.5. And then what is the spacing between your consecutive critical values? 2.5, right? And those need to be somewhat scaled appropriately, okay? So that's really the only reason we do that. Okay, so now I'm going to go over here to my graph, and I'm going to put down my first positive critical value at 0.5. I'm not going to put my y-axis yet. I'm going to put down 0.5, and I'm just going to do it kind of like it was over there, pretty close to the y-axis. And now I'm going to kind of just imagine, you know, coming out a little bit further and calling this the next critical value, right? And that would be 3. And that is where I can now draw my vertical axis, okay? And now that I have this spacing, I'll highlight it. Now that I have this spacing, I can visually eyeball putting the next one, and then the next one, and the next one, and the next one. And you only need 5 critical values for one cycle. I have more than 5 there already. I have 6, so that's enough. But you always need to show at least one negative critical value. So if I kind of keep that spacing, the next one will be there. All right, now all that we have left to do is to label them. How far apart are all your critical values before and after a shift? 2.5. Yeah, that's your quarter cycle interval. So you can either just bisect, or you can still take 1/4 of 10. So I'm going to count by 2.5s. Let's go backwards first. What would 0.5 minus 2.5 be? -2. So that's what that one is. And then 3 plus 2.5 is 5.5, plus another 2.5 is 8, plus 2.5 is 10.5. And I've got one more, so plus another 2.5 is my lucky number 13. Yeah. Okay, so there it is. So notice for the first time now, for y'all, the first time, the y-axis is not a critical value. All, right? And notice the spacing. What some students want to do is always include 0, and they'll put the 0.5 just as far away from the y-axis as they put the 3 away from the 0.5. And then your graph is going to look like it, you know, got kicked in the shin. It's not going to be symmetrically horizontal. All right, so now we've got the table set. Now we'll put the food on the plates, and we return up here, and it's just a kind of a positive cosine, right? Which is Chala. So by the Chala method, we go to our new origin, which is at 3, 3, and Chala means it starts high. There you go. So once you have a high or low point established, everything else falls into place. So I'll go from right to left first, putting my other critical values, something like this. And then I'll go to the left. So it should be at 0.53 and then at -2, 1. There you go. And now I'll eat, right? So now we connect the dots with exaggerated smiles and unfortunately exaggerated frowns. But, you know, tongue in cheek, we're not really sad, I hope. And then we turn the corner extend it out a little bit. So notice that it looks symmetrically horizontal. If you accidentally include the y-axis as a critical value, it's going to look really, you should notice that. It's going to look funky. So again, your y-axis and your x-axis do not have to be scaled the same, but your y-axis has to be relatively to itself and your x-axis relative to itself. Okay. And then once we have this, let's go through here. We can write other equations. If I want to start at -2, which function would start at a low point? Plus or minus sine or plus or minus cosine? Which one starts low? The minus, not sine. Sine always starts on an axis, right? Sahala, the first letter after S is A. Cosine always starts at an extreme. Cosine is extreme. Think of cosine as the one that drinks the Mountain Dew, right? He's extreme. So a negative cosine would be a low point. At 0.5, we're on an axis going up. That would be what? Plus or minus sine or plus or minus cosine? Positive sine, yeah. Remember, if it's up or going up, it's always positive. If it's down or going down, it's negative. So at 3, we add a high point. That would be positive cosine. At 5.5, we add an axis going down. That would be negative sine. And then completing the full cycle here at 8, we're back at a low point. That's negative cosine. So really the only thing that's going to change then is the phase shift. So let's just go ahead and write. We already have a positive cosine, so let's not write another positive cosine. Let's just do 3 more. I'll use g of x, and let's do a negative cosine. So now instead of +2, it's -2 cosine, parentheses, 5/5, parentheses, x. I always like to set it up first, close, plus 3. And now the only thing I need to change is the phase shift. So we already have it marked. A negative cosine could be at -2, or it could be at 8. If I want to do the -2, what would it be inside here? +2. And if I wanted to do the +8, it would be -8. So I'm going to write it kind of like that. Does that make sense if I write it like that? Or x +2 or x -8. Maybe I'll squeeze a little or in here. Or there we go. Yeah. Okay. Cool. A, B, C, D, E, F, G, H. We'll do H of x. All right. Let's do negative sign so we can end on a positive. For negative sign, it's going to be now -2, but now it's sine, and everything else is the same except for the phase shift. 5/5, x plus or minus something plus 3. For negative sign, we're looking for a place that is on the axis going down, and we only have one of those shown. It's at 5.5, so it would be the opposite sign here, minus 5.5. And ending on a positive, A, B, C, D, E, F, G, H, I. No, we don't do, let's do J. Yeah, let's do, yeah, J. Yeah, Lord. J, K. J of x is +2 sine, +2 sine. 5/5, x plus or minus something plus 3. And now the only thing that's different is the phase shift. So for positive sine always starts on an axis. We're going up. And I've got 2 of them, right? 10.5 and 0.5, but what the heck? I'll use the 0.5. So it's going to be what? Plus 0.5 or minus 0.5? Minus 0.5, yeah. But if this were a multiple choice question on a test, I'll also have plus 0.5. Yeah. Ooh, yeah. So there you go. So that's why we work hard to get our graphs all beautifully like that laid out, so that we can then easily and quickly write other equations with no distracting information. All right, questions on that one? All right. Sweet Caroline. Dum, dum, dum.